So section 11.6 is kind of an important section because it sets us up for solving exponential logarithmic equations in section 11.7. If you actually looked at the syllabus, I think I've got a full day and then some assigned just to covering section 11.7. There's a lot in there we're going to need to practice. But let's remind ourselves of a few things here. Who could start me out here? When we multiply things with the same base, what do you do with their exponents? Add them. Thank you. A to the n plus m. And how about dividing things? Cancel them? Ooh. Subtract would be better, yeah. A to the n minus m. Now when we developed the logarithm, it was as the inverse of the exponential function. So the logarithm is going to have some properties that are kind of like this. So for instance, when we take the log of a product, say the log of x times y, well, when I had a product here, I added the exponents. And when I have a product here, I'm going to add the logs. That's going to be equal to the log of x plus the log of y. So it's kind of a bizarre property to have, but it's a very useful property. We're going to use it a lot. How about over here? Let's take a look at the quotient, log of x divided by y. Now when I took the log of a product, I added the exponents. What do you think I'm going to do when I take the log of a quotient? What do you think the rule is going to be?
Subtract them?
Yeah, subtract them. Well done, Josh. So it's going to be log of x minus the log of y. One quick note. That's not what you can't do when you're working with is say, oh, that's the log of x divided by the log of y. That's just not true. All right, so there's actually a lot of properties of logs that you can work with, and there's a nice little list on your handout. So let's take a look at some of those things there. So in addition to our product rule and our quotient rule, we've also got a power rule. Sometimes I regard this as the parachute rule, because this guy, little n here in the exponent, kind of parachutes out front, lands in front of the log. And there's a couple other properties that follow from this. There's one more that we're going to have to add to this list as well. But let's start out with looking at what it's going to mean for us to use some of these properties. For instance, this is what you're going to see in some of your homework assignments on WebAssign, where you've got the log of a quotient. Let me see if I can't squeeze in. Let's see. No, I'm missing all my good writing utensils. Maybe I can do it this way. So you've got that log of a quotient. Now what the log of a quotient is it's going to become the log of the numerator minus the log of the denominator. And what they're asking you to fill in here is the s and the t. S times t. And that's it. So you're just using the quotient rule first. How come I didn't use the product rule? Well, because you got to break it up into numerator and denominator separately before we start working with the product rule. Here we can work with the product rule. So this is going to be the log of s plus the log of what? T. And that's it. And one thing that you got to be careful of is this right here. And there's the last little bit here. When we expand this, it's like there's a parenthesis around this. And there's that parenthesis. If I got rid of that parenthesis, what's that negative going to do to this term here? It's going to make it a negative. It's going to distribute. So that's going to put a negative there. That's something that's very easy to make a mistake on. We'll probably see that again and again a few times. But there it is. That's all they're looking for you to do is to complete the solution here by filling in the different properties of logs that you use here. Now, before I get to some of the next ones, let me give you a couple reminders, or ask you to remind yourself. Log base 10 of x. What's another notation for that? What else could I write here?
Log x.
Yeah, just log of x, right? Because the 10 is kind of understood. How about log base e of x? Anyone got that one? ln of x. Good. So this is your common log, and this is your natural log. The natural log always has base e. It's understood that this has a base e when you're writing ln. I like to write it like this. I think it makes some of the properties a little bit more obvious to see here. So let's look at a few of these, starting with this one right here. Example, well, actually, you know what? Before I do that one, let's fill in this one. Log of x times, or 7 times x times y times z. So it's this log of this whole product here. And I'm going to give you kind of the fast version of this. If you have a log of a product, it becomes the sum of the logarithmic terms. So we could expand that as log of, this should be a 7 first. Log of 7 plus log of x plus log of y plus log of z. And that's it. That's all they're looking for you to do, is to expand that like that. 2. Let's hop on down to these examples. So this is continuing with example A. Get the ln of e. And what I want us to do first is to realize that this is really log base e of e. Now we got to think back and remember what the logarithm is asking us to evaluate. It's asking us what exponent of the base gives me that number. We did a bunch of these last time and before then as well. So for instance, as a quick reminder, if I had log base 3 of 27, the question is what power of this gives me this? Well, 3 to the third power gives me 27. How about here? Can anyone figure that one out? Yeah, it's 1. Let's take a look at it on our calculator. So on our calculator, it would look like this. You could do ln of e. Now as a reminder, e is right above the division sign. So you hit the second key, then the division sign. ln of e should give you a 1. Great. How about the next one? ln of e squared. Well, I'm going to make my life a little bit easier here. I'll hit the second key and then the ln, or the enter key. Just go back and I don't need to put an exponent here. I want to make that a squared. Any predictions? What power of e is going to give me e squared? 2. Yeah. E to the second power, or e to the second power gives me e squared. So the answer is 2. And if you actually look through at some of these, we can start making a little bit of a generalization. So the next one over is ln of e cubed. Any predictions for ln of e cubed? 3. Nice. Now the property that kind of reflects this is right here. When you have log of some base of that same base to the r power, you're just going to get the r. You're just going to get the exponent. So that's a nice property to kind of have around. Makes it easier for us to simplify things. And let's see if it applies to either of the last two. So either the last two would look like ln of 1 over e. Now you could do that on your calculator. Tell you what, why don't you try it on your calculator first, and then we'll make sense out of it next. So let's do ln of 1 divided by e. What'd you get?
-1.
-1. Let's see if we can't make sense out of that -1. And I guess the way I could make sense out of this is I could write this as ln, actually better yet, log base e of e to the negative first power, right? Because e to the negative first is really 1 over e, so I get my negative 1 there. Let's take a look at the last one, ln of 1 over e squared. How would I rewrite that one? Iris, any suggestions?
E to the negative second power.
Nice, e to the negative second power. And Charlie, what do you suppose I'm going to get when I do log of e to the log base e of e to the negative second power? Negative 2. Yeah. So when these match, the base of the logarithm and the base of your exponential function, you're just going to get this exponent there. And that's kind of a cool property. Certainly something to take note of as you're working through some of these things. All right, let's keep going with a few more here. The goal is to practice a lot of these things. I can't say this is going to be the most exciting section of the entire course. Basically, this is a lot of grunt work to set us up for section 11.7. But, you know, we'll do our best to have some fun along the way. Example B. We've already done the first one, so let me move on down to the second one. Log of 7c over 3. Now, one of the things you might see here is a product in the numerator, but I can't do that product yet. What do you think I have to do before I do my product rule? This is part of a quotient. So I've got to start out by using the quotient rule. Pfeiffer, what would it look like if I use a quotient rule here?
Would you break it up into log 7 plus log c, or no?
Eventually I will, but I'll start out with a numerator and denominator. So log of 7c minus log of 3, and then I'm going to split this up. Now, unfortunately for us, out in front of this is a 1, so I can just kind of split it up like this. This is the product rule, log of 7 plus log of c minus log of 3. And we're looking pretty good there. That's it. So when I ask you to expand these things, and that's what I'll probably put on the test, is expand. That's what I'm looking for. Looking for you to use all your rules for logarithms, or all the rules for logarithms. That's these, and we're going to add one more to them. Use them until you can't use them anymore. Mostly it's going to be your product rule, quotient rule, power rule. These are handy as well. Let's try the next one. Log base 6 of x over 216. So, Carl, start us out. What this going to look like as we get started with this one?
Use the quotient rule.
Yeah.
Log base 6x minus log base 6 216.
Nice. Log base 6 of x minus log base 6 of 216. I'm not sure WebAssign is going to give you full credit on this, or any credit. I'm not sure how they would grade this one, because there's something else I can do here. Does anyone see what else I might be able to simplify? It's probably not very easy to spot, and I'll help you out with it in just a second. But what do you got? Anything? Well, I don't expect you guys to be familiar with these numbers enough to do this in your head, but log base 6 of 216 works out pretty nice. Now, I'm not sure if I've shown you this or not, so let me do it right now. If you don't have a graphing calculator, you're going to be kind of bummed. Let's see. Let's clear out all this stuff so you can kind of keep track of my keystrokes here on the bottom. And what we need to do is we need to do log base 6 of 216. Now I'm most familiar with finding this key from the math menu, and then go over to the right once to get up to numbers. So math, and then to the right. And then my shortcut is to go up. Where is it? Where is it? Ah. All right, maybe I lied. Where is it? Yeah, no, I think I should have just started at the math menu. So let me start this again. So when we go to the math menu, you just go up from here, and there it is, log base. So let's enter that. And gee, we want log base 6 of 216. Well, log base 6 of 216 is 3, because 6 to the third power gives you 216. Oh, isn't that special? That's really cool. I would have given like a lot of money to have this key when I was a student. That's so helpful. All right, so what's that mean for us? Well, let's just put in that 3 there. It says log base x minus 3. And that's it. We're done with that one. Let's try another one like that, kind of skipping to the end of these. And I'm seeing a couple little typos on my handout here that I'm not happy about. Log of 1,000 over 3. Marcellus, it's not really written, but what's the base that's understood to be here? Not 1. Some help?
Is it
10. It's understood to be base 10. All right. So that's going back to this over here. All right, let's keep going. We're going to start out with the quotient rule. So, right? What would the quotient rule say here? Go ahead. Log of 1,000 minus log of 3. Think we're all done? Now, it's not really written, but maybe you can do this one in your head. I bet you at least some of you can. And if you can't, that's fine. It's understood this is a base 10. What power of 10 is going to give me 1,000? 10 to the third power. So that'll equal 3 minus log of 3. And you don't have to write the base 10. It's just helpful in terms of thinking about some of these things to write that sometimes. So are we okay with this one? Let's keep on doing some more here. And what I'll do is I'll make them harder because I know you're enjoying yourself. So let's move on down to example C. Example C. Log of 6xz to the 7th. Now, I put the parentheses there just to kind of emphasize what you're taking the logarithm of, and also to emphasize the fact that the 7 only applies to the z, doesn't apply to the whole thing. So for instance, one thing you can't do is you can't use the power rule right away. You can't take that 7 all the way out front. We got to do something first. What would that something first be? There's nothing to distribute yet. Product rule. So right now what we're looking at is just a product. What did I say about the products? We did one earlier. When you have a product, actually right here. When you have a product, it just becomes the sum of those logarithmic terms. I mean, I could show you kind of longhand how that comes about, but the easiest thing to do is just realize that that's the sum of the logarithms. So in this case, log of what?
6.
Plus log of x plus log of 7, or z to the 7th. Now again, you're not going to be all done. WebAssign's not going to give you points on this, I don't believe. So, what am I missing? What else could I do?
Put the 7 in front of the log.
Ah, well done. Thank you, Pfeiffer. Put that 7 out in front. That's your power rule for logarithms. So, log base 6, or excuse me, log of 6 plus log of x plus 7 times the log of z. It's natural and understanding to be skeptical of some of these things. So let's just kind of do a numerical example of something like this. Because a lot of you are probably looking at it going, really? Is that right? How does that work? So let's just do kind of a simple example here. Let me clear these out. And I'll do the log of, let's do 48 raised to the 3rd power. All right, and I need some number like that. Now, what's the power rule say here? I could rewrite this and calculate it somehow else, right? What would that be?
3 log 48.
3 log of 48. So if this property is actually true, what should happen when I press the enter key? Should be the same. They're looking remarkably similar, aren't they? Yeah, they are the same. So as strange as this property might seem, it is a legitimate property of logarithms. Let's keep going. Let me skip down to log of x, y to the 6th, z to the 7th. And give you a moment on that one. If you're watching this later at home, then pause video, give yourself a chance to answer that first. Who's got that first step? What's a first step going to look like? Keep going, Masson. Oh, I'm sorry. I'm sorry, my bad. Keep going, Kayana. Nice, nice. Finish it up then. What's our finishing step? Heba?
Log x plus 6 log y plus 7 log z.
Nice, perfect. So again, you're using the product rule followed by the power rule. Those exponents come out front. Kiana?
On the test, do we have to show our work like that, or can we just,
No, I guess it depends on how complicated the expressions are. Sometimes I do generally like to see your work. This one I can kind of see that you can do it in your head, But where I draw a line is where it's too difficult for me to do all in my head. If you do that much work in your head, if you're doing more than I do in my head, then I might get a little bit unhappy. So, yeah. The nice thing about you showing your work is that if you make a mistake someplace here, I can see it, and then I'll just take off a little point here because I can see your work. But if it's wrong and I can't see your work, then it's just wrong. So it's up to you. But yeah, I can understand people could do this in their head. No. Let's try log base 8 of 1 over 8m. So a little bit different on this one. There is a little extra something else at the end that you should take care of.
Yeah.
Okay,
Yeah.
nice, nice. I'm impressed. Because it looks like 8 to 8 amp.
Right.
And then that would be something different. Okay, there's something you can simplify there still.
I only have this.
There's only one handout today. Look for some extra simplification on this one. There's actually 2 things that you can simplify. That'll work out pretty nice. Okay, let's see which it'll start like this, but then there's a couple more things you can do to simplify that. Okay. Don't forget it's base 8, log base 8. So it should, but the base still has to be here, log base 8 of 8. And, something happened to, oh, is that a 1? You have to take the log of something, you can't have, it'd be kind of like having square root of that. But you need a number there, so you need a log of something. Yeah, so log base 8 of 1. So that's where, it's a start, yeah, but you gotta keep going. Log base 8. Well, what rule are you gonna use first? Well, I guess it depends on what you're seeing here, but which of these rules do you think you're gonna use first? You lost something here. You lost your minus. Because that was minus this, so it should be minus of all that. All right, so definitely getting a little bit harder. Now there's a couple ways you can do this one. I'll try both. So the first thing you see when you look at this, and think about your rules, right? You've got a product rule, a quotient rule, and a power rule. Which one of these are you going to apply first? Is this a product? not exactly. There's a product in the denominator, but it's not a product itself, not the way it's written right now. Yeah, you have to start with the quotient the way it's written right now. So it's going to be log base 8. And please do me a favor, write the subscript here as a little bit below the line, maybe a smaller font than the rest of this. Log base 8 of 1 minus log base 8 of 8m. Now there's a couple things you can do to make your life a little bit easier. One of them, not a bad idea, would be to put parentheses around that. Because if I don't, a lot of times people expand this and get kind of the wrong thing. So how about log base 8 of 1? Did anyone calculate that? Oh, it's 0. Yeah. You can calculate that directly in your calculator, but let's think about it. What power of 8, or 8 to what power, gives me 1? Well, 0. So this is just a 0. Minus all this. What am I going to do with this part right here? Say again? Yeah, you're going to use the product rule. So if I did the product rule and I wasn't being careful, if I didn't have these parentheses there, I go, oh, minus log base 8 of 8 plus log base 8 of m. Where's my mistake? Yeah, that negative, if you're writing it without parentheses, that negative has to distribute itself. Before I distribute, can I simplify what I have in the parentheses at all? Charlie? Yeah, what power of 8 gives me 8? Well, the first power. So overall, I've got a minus of 1 plus log base 8 of m. Or if I distribute that, I get minus 1 minus log base 8 of m. I don't care which one you do down here, but you are going to have to use both of these things here. That log base 8 of 8 is, log base 8 of 1 is 0, log base 8 of 8 is 1. Both of those are kind of special little properties up here. Whenever you take the log of whatever base of 1, you're going to get 0. Whenever this matches this, you're just going to get 1. So both of those are kind of our special properties, kind of side cases from the main properties. Kiana?
Did you write the log base 8m like on the same line as the log 8, base 8 to the 8? Or is it like supposed to be down somewhere?
The 8 here is supposed to be down a little bit from the log. So this is just telling you the base, so it's a subscript. So, and I'm sorry if I'm not doing it, nice justice. If we look at the handout, maybe it's a little bit better because it's in type. But you can kind of see here that, for instance, the A here is a little bit below the line of everything else, right? It's a smaller font. It's a subscript. So it is something that I do want you to be a little bit careful about because, let me see here. If I was to write log base 8 of m, well, if I'm not careful, this looks like a product. It looks like 8 times m instead of log base 8 of m. So those are different things. These aren't equal. So do be careful of writing the base as a subscript. Oh, I'm sorry. Sorry. All right, so let me repeat myself here. So if I have log of 8m, if I'm not careful, if that 8 drifts up, that's a much different expression than log base 8 of m. So here, this is log base 10 of a product. Here, this is just log base 8 of m. So You got to be careful because these things just aren't equal. They're different things. So sometimes, I can kind of work around things and cut you some slack, because sometimes it's just wrong. So do be careful with that, please. I think it was Stephanie's paper that I swung by and saw her do things in a different way. It was kind of cool. So let me revisit this again using Stephanie's approach. Stephanie, I think you noticed this is one of your properties, right?
Yeah.
You're like, oh, I've got the log of something over, 1 over something. So I can use this property. I just take minus the log of the denominator. And what's happening there is that when you take the log of the numerator from the quotient rule, that numerator is just going to have a log of 0. So you're just stuck with the minus the log of the denominator. Let's see what nice shortcut that gives us. So let's look back at this for just a moment. It's going to be log base 8 of 1 over 8m. And we can immediately cut that to minus log base 8 of 8m. Now, whenever there's something in front of your log that is different than 1, you've got to be careful when expanding. So what I always like to do for myself is I'll put parentheses here. That way I know that eventually I've got to distribute whatever that number is. If it's a 1, you're fine. You don't have to worry about this. But if it's something else, we do have to worry about it. Equals negative. And then we can expand this. Log base 8 of 8 plus log base 8 of m. And as before, that's a 1. And then the rest is pretty much the same. You could write that as minus 1 plus log of base 8 of m or distribute it that and finally get minus 1 minus log base 8 of m. So a different way to do that. In general, there's a lot of ways you can do these types of problems. It's just going to be, well, what hits you? What do you see first when you do these things? Okay, that was a tougher one. Before I get to the toughest one of example C, are we okay with one of these methods for this example? So we did the same problem 2 different ways. Does at least one of them resonate with you? Charlie?
Do you want to put like a real number in front of the log, or not real, but a whole number of usually?
No, you don't necessarily have to have a whole number. In fact, in our next example, we'll see something with something other than a whole number. We'll have a fraction. Yeah. But it doesn't have to be a nice whole number. In fact, a lot of times it's not. Good question. Anything else? Stephanie? Doing good there? So keep in mind that on the test, when I give you something like this, the instructions are going to be to expand the logarithm. So I think there's an urban legend about somebody's handing a test like this where the instructions were to expand the log, and the problem was like this, and the answer proceeded with this, and then this, and then this. All right, that's not exactly what I mean when I say expand the log, okay? Just putting that out there in case anyone, is feeling a little frisky on their exam. This is not what we're looking for, but it is kind of fun to look at. The last one. So let's take a look at the last one. And let's see here. So that's this one. Log base 3 of the 7th root of x. So Charlie, this is a direct answer to your question. You're not always going to have nice whole numbers out in front. In fact, to kind of get started on this one, let's take a look at this thing right here. I think the hardest part for a lot of people is going to be reaching back to chapter 9 and going, how do I write that again? Because if you notice, I didn't give you any properties of logarithms that deal with square roots, did I? Nothing. But we don't need them. Because you can rewrite this using exponents. So what would this be using exponents? X to what power? 1 over 7. It's not really written, but it's understood that there's a 1 here. The 1 comes up, the 7 comes underneath, and we get this. All right, so this one's going to be a little bit challenging, a little bit tricky. Be careful expanding this one, but try and get as far as you can. A lot of you guys are catching that negative on that second term. I'm really happy to see that. Okay, so first thing to notice is that this is really a quotient. You've got the log of something divided by something else. So we'll apply the quotient rule to this. It's going to be the log of the numerator minus the log of the denominator. So log of 3, or log base 3 of x to the 1/7 minus log base 3 of y times z. How come I couldn't take the 1/7 out to begin with? If the 1/7 was outside the parentheses, if that 1/7 applied to the whole thing, then I could. But it's not. The 1/7 only applies to the x, so I'm stuck there. And here's where I was really delighted in walking around. A lot of you guys realize that, oh, I need to expand this using my product rule. And of course, up here, what else can I use? What other rule can I use? Yeah, your power rule. So the 1/7 comes out in front. 1/7 log base 3 of x minus log base 3 of y plus log base 3 of z. If you want to leave it here, hey, I'm fine with that. That's fine. If you want to distribute that negative sign, that works as well. Either one is okay with me. So this or 1/7 log base 3 of x minus log base 3 of y minus log base 3 of z. Yay. All right, how are we looking on that one? Doing okay? All right. I think because this is taking a while, I'm going to break this video up into 2 parts. So we're going to stop things here.